of them together with the core layer. And finally, when geographic dispersion of the LAN switch across many buildings in a larger campus facility would require more fiber optic interconnects back to a single collapse core, we need a core layer. Actually, it can be cost effective or it can reduce the cost. Here in this picture, you can see different places in the network. We call them the places in the network, or PIN. Okay, for example, we have WAN edge, we have data center, we have internet edge, we have network services. In WAN edge, we have distribution layer switch connected to the core, also in the internet edge, also in the network services. But in the data center now, we use a newer version of design. We call it leaf spine design. This is a little beyond the scope of our course, but let me to say that here, the most traffic is east-west traffic, and because of that, the usage of the leaf spine design can give us the better performance in compare with the hierarchical design that is suitable for the north-south traffic flows. Because of that, here we use in the data center leaf spine design, and as you can see, the switch here, these two switches connected to the core layer. Don't worry about the detail of data center now, but here it is important to say that now we use three-tier design. With this three-tier design, we have communication between the endpoints and end users with each other, and also with the WAN edge, with the data center, with the internet edge, and with the network services. This is our enterprise network architecture in the three-tier design. Alright, until now we learned about the two-tier and also three-tier model of design. Don't forget, between the access layer switch and also distribution layer switch, in each of these two models, we can use layer 2 link or layer 3 link. In the traditional network design, always we use the layer 2 switch in the access layer and also the MLS or multi-layer switch in the distribution layer. Because of that, the link between the access layer switch and the MLS only can be layer 2, okay? And as you can see here, we have two options for design. The first type of design is that we can restrict the VLANs to only one switch. As you can see here in the left network design, between the access layer and also between the distribution layer, the VLAN 10 restricted only to this switch, okay, and VLAN 20 restricted to other switch. Because of that, actually, because here we don't have any VLAN 10 member in this in the right switch, actually we don't have any possibility of loop. Actually, this link work only for VLAN 10, and these two links are working only for VLAN 20. Because of that, here we can see this is loop free, but the restriction is that we don't for example, assign VLAN 10 to other switches except than the, for example, first switch. If you use this model, actually, if you restrict the VLAN 10 to only one switch and VLAN 20 to only one switch, you can use the bandwidth of all of the links. Actually, STP doesn't block each of these interfaces, okay, here. But in the right scenario, as you can see, we have the loop topology. In the loop topology, VLAN 10 can be available in all access layer switch. Because of that, here now we have a loop. STP can block interfaces. Look at here, when you use the loop free design, means the VLAN 10 only is available in one switch and VLAN 20 in another switch. The link between these two distribution switch can be layer 3. Because of that, actually now we don't have any loop. Also, if we want here, we can use FHRPs or first hop redundancy protocol. You know that with the FHRP, we can use the benefit of the link with the router redundancy. FHRP is the abbreviation of first hop redundancy protocol, and we have three protocols, include the HSRP, VRRP, and GLBP. HSRP is the abbreviation of hot standby router protocol. VRRP is the abbreviation of virtual router redundancy protocol, and GLBP is the abbreviation of the gateway load balancing protocol. We can enable FHRPs between these two router or these two MLS And because of that, when, for example, one PC as a member of VLAN 10 wants to send traffic to the, for example, external networks like the other VLANs, like the internet or some other places, it can use one of the routers as the active router. And if the active router failed, it can use the other router, the standby router. In HSRP and VRRP, one router is the active router, okay, and other router is the backup router or the standby router. Because of that, actually we have only fault tolerance. But if you enable GLBP or gateway load balancing protocol, here we have the option of the load balancing. We can send traffic from both router to the outside. Okay, but when we use the loop topology, and you know that this link is blocked, for example, for VLAN 10, this link is blocked for VLAN 10, and now only we can see the one of the switches here is the active switch. Okay, actually we don't use this switch, this distribution switch. Let me to show you. Assume that here we have distribution 1. This is the distribution 1 switch, and this is the distribution 2 switch. Okay, when we use loop free, okay, it means that we have one restriction. The restriction is the VLAN 10 should be only restricted to one switch and VLAN 20 to other switch. Because of that, we don't have loop. Okay, and because of that, the STP doesn't block any interface, and for VLAN 10 we can use both of these two links, and for VLAN 20 we can use both of these two links, and the link between distribution 1 and distribution 3 is the layer 3 link. Here you can use one of the FHRPs like the HSRP, like the VRRP, like the GLBP. Okay, and you know that GLBP is the most efficient protocol because we have the option of load balancing. Actually, the computers in the VLAN 10 can use both of these distribution switches. Okay, and also here the computers in the VLAN 20 can use the distribution 1 and distribution 2. Okay, but when you use the loop topology, it means that you are propagating the VLAN 10 interfaces in multiple switches. Okay, here we will have loop. For example, the first thing that it is important for us that the link between these two switches should be layer 2 for connectivity between the VLAN 10. Okay, and after that, this two link, or for example, if the distribution 1 is the root bridge, will be blocked because this is the root bridge, and all of the interfaces connected to the root bridge are up or forwarding, and these two interfaces will be blocked. Because of that, here we cannot use the GLBP. Actually, we can use only HSRP and VRRP. Actually, here we don't have the benefits of the load balancing. Only we can use these two protocols for their fault tolerance. Look at here. Assume that we have a PC connected to the VLAN 10 of this switch. Okay, and also we have the next PC again connected to the VLAN 10 of the right switch. Here you know that we cannot use GLBP. For GLBP, this PC needs to send its traffic to both of these two distribution 1 and distribution 2, and as you can see, this link is blocked or this link is blocked. Here we can use HSRP or VRRP. Because of that, we can say about the layer 2 access layer, it is recommended when we use STP, it is recommended to use the loop free with one VLAN per access switch, and we should prevent to use the loop topology with VLAN spanning access, multiple access switch. This is only a recommendation, but in some cases maybe you need to for example, propagate the VLAN 10 interfaces between multiple switches, and in that time you can use the loop topology. But if it is possible, it is recommended to use the loop free design between the layer 2 and layer 3. Don't forget, we talk about the conditions that we have layer 2 only switch and multi-layer switch in the topology between the access and distribution. Okay, because of the here we have only two options. The first option is that we use loop free design or loop topology design. Okay, but if your MLS can support your access layer switch support the multi-layer switching, here we have other options. In this design, the switch, as you can see, the access layer switch support only layer 2 switching. Because of that, we need to use layer 2 link. For designing of layer 2 links, we have two options, loop free and loop topology. Now, let me to explain the next condition that maybe we have in the access layer. We call it layer 3